Welcome back. So earthquakes occur. Energy is released in the form of seismic waves. How do we measure earthquakes? Well, there's a few different ways to do it. Two main ways that we'll talk about. So if we're measuring what's known as the magnitude, so the measurement of magnitude measures the total amount of energy released in the earthquake. We typically use the Richter magnitude scale to help determine that by measuring distance from the epicenter of the earthquake, the fictitious point above the focus, and the maximum amount of ground displacement due to the S wave. Typically, we're looking at the S wave, not the P wave, because the S wave, a little bit bigger, tends to do more damage, shakes things a little bit more. So yeah, the Richter scale, this is probably the thing that you hear on the news or in movies when they say earthquake. There was a 7.0 earthquake today in California. That's the Richter scale. All those numbers I was referencing to earthquakes in Arizona, that was the Richter magnitude scale. Again, it's a measurement of energy. This is the Richter scale is a logarithmic scale. I'm going to get a little mathy here, which means that an increase from one integer to the next integer isn't just a little bit more shaking of an earthquake, not a little bit more energy release, a lot more. So when we're going from, say, a 7.0 to an 8.0 magnitude earthquake on the Richter scale, that's 10 times more movement of the ground and 32 times more energy is released. If we take that another step, going from a 7 to a 9, so logarithmic, so it's multiplicative. It's not 10 plus 10, so 20 times more movement. It's 10 times 10. So let me move me. So 100 times more movement from a 7.0 to a 9.0, 1,024 times more energy released. So as you go up the Richter magnitude scale, which starts at 0 and then builds its way up, each step gets multiplicatively larger. It's not just adding, it's multiplying. So each step kind of gets bigger. Now, the thing with the Richter scale is it measures energy released. It doesn't really do a good job of describing the destruction or what was felt. It's just a measurement of energy based on a couple of other measurements. So it's somewhat more meaningless to the non-scientist. If someone said, oh, there was a magnitude 9.0 earthquake in the ocean. Okay, well, did anybody feel it? No. Well, okay. So all its energy was released, great, but no one felt it? No one died? Nothing was destroyed? Okay. So the Richter scale works great for scientists, knowing energy and how much energy was released, but for the common everyday person, for them to use that on the news or in the movie, it's somewhat meaningless. Looking at the number of earthquakes the past 10 years up until the end of last year, 2021. So the total number of earthquakes kind of hovers around 12 to 16,000-ish. You can see this past year, 16,000 earthquakes. Now, the lower an earthquake is on the magnitude scale, the more common. The bigger magnitude, the bigger, more destructive earthquakes, obviously the far less common. So these numbers aren't too far off the averages. So when we're looking at, again, kind of light earthquakes, 4 to 4.9, the average is around 13,000, and we kind of see that. Moderate, around 1,319. Again, we kind of see that. There's some more, not too much less, but some more. Strong, 6 to 6.9. Around 134 on average. Yep, right in that ballpark. 7 to 7.9, around 15. Yep, right in that ballpark. And then 8 or higher, which is considered a great earthquake. On average, we get about one of those a year. 3 of those last year. But on average, about one a year. When you start to get up to a magnitude 8.0 or above, that's a lot of energy. It's a lot of movement. But on the other end of the spectrum, which isn't up here, so through 3.9 or lower, we're looking at, those are millions of those. In fact, as far as minor earthquakes, not much energy released, 2 to 2.9 on the Richter magnitude scale. There's 1.3 million of those a year. That's approximately 150 per hour around the globe. So earthquakes are very common. Big earthquakes are not common. The way the Richter magnitude scale is determined is using a device called a seismograph. This is the thing that you'd see on the movies. There's nothing, and then the earthquake starts to come, and all these scribbles start occurring as the earthquake is occurring. That's a seismograph measuring earthquake wave amplitude, the amount of energy released. You can see kind of the actual image up here. So basically, it's a rotating drum, and you have kind of some source that is some pendulum kind of tied to this supporting column. And if the ground shakes, then this starts to shake and creates a scribble. Now, that's kind of historically how it's done. Now it can be all done digitally with computers and different sensors. But nonetheless, we can still look at these scribbles, and it helps us figure stuff out. And we'll do that a little bit in this class. So again, looking at on the lower end of the scale, minor earthquakes, we're getting 1 million plus of these a year. And so this kind of graphic looks at kind of the size of earthquakes compared to what how much energy is equivalent to that. So if we're looking at a light earthquake between a 4 and a 5, that's about as much energy as a tornado. An earthquake between 6 and 7, which is a strong earthquake, create billions of dollars of damage, can create loss of life. It's pretty much equivalent to an atomic bomb explosion. When we start to get up, in the 8s and the 9s, there's really not much stuff to compare. The largest volcanic eruption that we know of would be equivalent to around 8.5. Mount St. Helens, about a 7.8. So as we get 9 or above, that's uncharted territory. That's energy beyond anything else equivalent in nature that we can really come up with. So the biggest earthquakes in regards to Richter magnitude as far as energy released. Again, this doesn't mean destruction happened. This Richter magnitude scale is a measurement of how much energy. Now, if there's a lot of energy released and these places are near cities, there's going to be a lot of death, a lot of destruction. But in general, the biggest historical earthquakes, you can see the largest ever was in Chile, a magnitude 9.5 on the Richter scale, happened in 1960. Right behind it, 9.2 in Alaska, 1964. Indonesia. Hey, the fourth most populated country, just on the southeastern edge of Asia, these series of islands. In 2004, we had 9.2. More on that earthquake. 2011, more on that earthquake in a little bit, 9.1. And then in 1952 in the Kamchatka Peninsula of Russia. What you'll notice is that all of these tend to be right around the Pacific plate, right along what's known as the Ring of Fire, an area of the world where there's a large amount of earthquakes and a large amount of volcanoes. So the 5 biggest earthquakes, all around the Pacific. You want to know where the most dangerous place on Earth to live is? All around the Pacific. So that's magnitude, release the amount of energy released. But then there's also a measurement that measures something called intensity. That measures the maximum intensity of shaking at a location. And intensity is what you feel and the destruction done. Because the shaking varies from place to place in a given earthquake, so does this measurement. Now, this intensity measurement, which we use something called the modified Mercalli intensity scale, which is used to measure it, is based on descriptions of what people felt, what people see, and the damage that has occurred. This makes the intensity measurement, as opposed to magnitude, so this makes intensity much more meaningful to everyone. Because if I were to say, there was a magnitude 7.0 earthquake in Arizona today, that doesn't tell me what happened, how much death, how much destruction. Whereas if I were to say, on the modified Mercalli intensity scale, the earthquake felt in Phoenix was a 6 on this scale, while in Avondale it was 5. On this scale, which I'll show you, it will tell us the types of destruction, what is felt. So it gives us kind of meaningful information. The further you get away from the epicenter, the lower this intensity measurement is, again, because the intensity is greatest at the epicenter. Same with the energy released. Measurement, these are the intensity scale, the modified Mercalli intensity scale measures from 1 to 12. Typically they use Roman numerals. And again, it's more meaningful to the non-scientist because we can base it on what we feel. I was sitting down still, I felt the earthquake, and stuff fell off my bookshelf. I use all that in reference to this scale to see kind of where that was. Let's see here. If I'm just saying, let's say I was just sitting down in my house and I felt the shaking and stuff fell off my bookshelf. So let's see. Felt by a few people under especially favorable conditions. Felt by a few people at rest, especially on upper floors. Felt quite noticeable indoors. Many people did not recognize the earthquake. Vibrations felt like passing of a truck. Let's see. During the day, felt indoors. Dishes, windows, doors disturbed, walls cracking, sensation of a heavy truck striking building. So, if stuff is rattling or stuff is falling, based on that, I'm guessing what I would have felt would have been a 4 on this intensity scale. So just based on descriptions, you can come back to this modified Mercalli intensity scale to put an intensity to it. And that helps us figure out, the death and damage and destruction that occurred. Again, if an earthquake occurs, the closer you are to the epicenter, the higher the intensity scale because more destruction and shaking occurs, and the intensity dissipates as you go further away. Which is different than the Richter magnitude scale, which assigns one value to the entire event, to the entire earthquake, which again measures how much energy was released, which is just a certain amount. And based on these measurements, we assign it one Richter scale value. But again, intensity will differ the further you get away from the epicenter. So we'll look at both of these measurement scales. Richter, a little bit more sciencey. Modified Mercalli, a little bit more meaningful to the non-scientist. So let's go ahead and pause here. When we come back, we'll talk about the impacts of earthquakes on society. I'll see you back here in just a second.